Hey, welcome to the Explainer. Today, we're going to tackle a skill that's absolutely essential for any Java programmer: file handling. You know that feeling, right? You write a program, it works great, but the second you close it, all your hard-earned data just disappears? Well, if that sounds familiar, you are in exactly the right place. So let's talk about that. You build this awesome program. It's doing its thing, holding all this great information. And then, bam! You close the window and it's like it never happened. It's all gone. And believe me, this isn't some weird bug in your code. It's a rite of passage for pretty much every new developer. You see, this is what we call the disappearing data problem. It's not a mistake. It's actually how computers are designed to work. And it's the whole reason we need to have this conversation about making our data stick around for good. So why does this happen? Well, any data your program keeps in variables is stored in what's called volatile memory. It's temporary, kind of like a thought. The best analogy is this. Imagine you're typing up a long document, but you never hit save. If your computer suddenly shuts down, all that work is just gone. Your program's memory is exactly like that. Okay, so how do we hit save inside our actual code? We need a way to make our data permanent. And in the world of Java, that permanent solution is called file handling. File handling is pretty much what it sounds like. It's the whole process that lets our program talk to files on our computer's hard drive. It can create them, it can read what's in them, and it can write new stuff to them. This is the key to making data persist long after our program has finished running. Now, to get data from your program into a file and then back out again, Java uses a concept called streams. And honestly, the best way to picture a stream is like a pipeline. It's a one-way street for data. When you're writing to a file, data flows out through an output stream. When you're reading, it flows in through an input stream. And you've basically got two main flavors of these pipelines. On one side, you have byte streams. These are for raw binary data. You know, things like images, audio files, videos, basically anything that isn't just plain text. On the other side, you have character streams. These are specifically built to handle text. They're smart about it, working with characters, which means they can handle all sorts of languages and symbols. For what we're doing today, we're going to focus on these character streams. All right, enough theory. Let's get our hands dirty. We're going to walk through the entire life of a file from a Java program's point of view. We're going to create it from scratch, write some information into it, read that information back, add a little more, and then finally we'll clean up after ourselves and delete it. First things first, we have to tell Java which file we're actually talking about. We do this using something called the file class. Now, here's a pro tip. This step doesn't actually create a file on your computer. Not yet. It just creates a little signpost in your code that points to where the file should be. So how do we make the file for real? It all comes down to one simple command: file.create_new_file. That one line of code is what tells your operating system, hey, for real now, make me a new empty file right here. It's actually pretty helpful too. It'll return true if it worked or false if, say, that file already existed. Okay, an empty file isn't much fun, is it? Let's get some data in there. And for that, we're going to use another handy tool called FileWriter. Using the writer.write method is super straightforward. You're just passing your text down the pipeline and into the file. But, and listen up because this is the one thing that gets everyone at first, you absolutely must call writer.close. Think of it like flushing the pipe or hitting that final save. If you forget to close it, your data might just sit in limbo and never actually get written. Awesome! Our data is saved. Now, how do we get it back? To read information from a file, we can use a class you've probably seen before, the good old scanner class. Yep, it's not just for keyboard input. And the best part is, the logic is almost exactly the same as reading input from a user. Instead of pointing the scanner at the keyboard, you just point it at your file. Then you can use a simple while loop with reader.hasNextLine to check if there's more text to read, and reader.nextLine to grab it, one line at a time, until you've read the whole thing. But hang on a second. What happens if we run our writing program again? By default, FileWriter is just going to wipe out everything that was already in the file. That's not always what we want. So what if we want to add new info to the end of the file without destroying what's there? That's called appending. And the fix for this is, well, it's surprisingly simple. When you set up your FileWriter, you just add one more little thing, the Boolean value true. That single flag tells Java, hey, don't overwrite this file. I just want to append my new text to the very end. It's a tiny, tiny change in your code that makes a huge difference. And finally, the last step in our file's lifecycle. What do we do when we're all done with it and we want to clean up our workspace? We delete it. Java makes this incredibly direct. You just take that file object we started with and call the .delete method on it, and that's it. The file is gone. Poof. So a quick word of warning, be absolutely 100% sure you want to do this, because with this command, there is no undo button. Okay, so you know the basic moves now. Create, write, read, delete. But to really write solid, professional-level code, you need to follow a few critical best practices. Let's go over the most important ones. There are 3 golden rules that every pro Java dev lives by. First, always close your streams. Forgetting to do this can lead to resource leaks that can crash your whole app. Second, you have to handle exceptions. File operations fail all the time. The file might be missing or locked, and your code has to be ready for that. And third, the modern way to solve both of these problems at once. Use what's called a try with resources block. Seriously, this feature is a total game changer. It automatically closes your files and streams for you, and here's the best part. It does it even if an error happens halfway through. This makes your code so much cleaner and safer because you literally don't have to remember to call.close yourself. So how does it work? It's simple. You just declare the resource you want to use, like this buffered reader, inside the parentheses that come right after the try keyword. That's all you have to do. By putting it there, you're telling Java, hey, you are now officially in charge of this file. When this block of code is finished, no matter what, you close it for me. This is, without a doubt, the standard preferred way to handle files in modern Java. Wow, okay. We've covered a lot of ground, from that frustrating problem of disappearing data all the way to writing safe, modern, professional-level code. So let's just do a quick recap of the biggest takeaways. So here's the bottom line. File handling is what gives your program a memory. Java does all of its file input and output using streams. You now have the full set of tools to create, read, write, append, and delete files. And most importantly, always use try with resources to keep your code safe and clean. And now, it's your turn. Don't just let this be something you watched. Go and build something. The best way, the only way to really make this stuff stick is to use it. So here's your challenge. Go build a tiny notepad-like program. Make it so you can open a text file, edit it, and save it. That is how you will really, truly master Java file handling.